Alright, so here we're going to look at sigma notations. Yeah, so these ones usually come up when you've been given a certain sequence, and then they ask you to express it in form of a sigma notation, sigma, which looks like this. Yeah, so we must understand that there are only two types of sequences, and that is arithmetic sequence and a geometric sequence. So your sequences will be limited to only these two types, unless otherwise under special cases. So let us have our first example that says this. So if we have 3 plus 9 plus 27 plus 81, yeah, so we have this, and then we are told to write this in sigma notation. So first of all, we must identify what type of sequence this is. Is this AP or a GP type of sequence? So I see that I cannot add or subtract a constant number to move to the next term, so this can be an arithmetic, so it should be a geometric. So to prove if it is a geometric, my common ratio should be the same. So my 9 over 3 should be equal to my 27 over 9, which should be equal to my 81 over 27, which I guess is equal because everything is given me at 3. Yeah, give me a 3, so therefore it is a geometric progression. So what next do I have to do after knowing that it is a geometric progression? I can come up with the nth formula, right, for finding the nth term. So looking at a GP, I know that how do I find the next nth term? It is found by saying a to the power, or this. Yeah, this is the formula. So what is my a? My a is 3. What is my r? My r is also 3, and then but this is to the power n minus 1. So I won't replace with n because I want to find the formula for the nth term. So therefore I'm just going to say this 3 be multiplied by this 3. So these are the same bases, so I'm going to add up the power. So this is going to be a 3 to the power 1, and then plus n minus 1. So this is going to be 3n. Yeah, so this is my formula for the nth term. So therefore my sigma expression is going to be my sigma I starting from 1 to, how many terms do I have? 1 2 3 4. So from 1 to 4, and then my this is this. So this is my sigma notation. So there we have it. So the next one that we can have is saying 16 plus 8 plus 4 plus 2 plus 1. So again here I have to identify what type of series this is. Is this AP or GP? So looking at this, can this be a AP or a GP? No, it's not. It can be an AP because if the number I can add or subtract here can give me the same here, can give me the same here, can give me the same here, so it should be a GP. So if it is a GP, therefore my r should be equal to what? That was, here it was 16 plus 8 plus 4 plus 2 plus 1. So my 8 over 16 should be equal to my 4 over 8, which should be equal to my 2 over 4, which should be equal to my 1 over 2, which is giving me 1 over 2. So this is I. So this is a GP. So having that, I still need to find my formula for the nth term. So again, I find the nth term by saying this to the power what? N minus 1. So my first term is what? A 16, and then my r is 1 over 2, and then my nth term is n minus 1. So here I can see that I can express this 2 to the power 4, and then I can also express this 2 inside to the power negative 1. So this is going to be n minus 1. So I can go further on by saying 2 to the power 4, and then 2 to the power negative n plus 1. Interesting, huh? So adding up these powers, I'm going to have something that says 2 to the power negative n plus 5. So this would be my sort of sequence, I would say. So I'm going to do this. So this being this, I'm going to keep this. So I'm going to say alright, so this is going to be 2 to the power negative n plus 5. So my sigma notation is going to be this I starting from 1, how many things did I have? I had a 16, 8, 4, 2, 1. I had 1, 2, 3, 4, 5. I had 5, so starting from 1 to 5, and then this is to the power 2 minus n plus 5. So if I plug in my 1, it should give me a 16. Yeah, it's going to be 2 to the power 4. If I plug in my 2, it should give me that. Yeah, so this is my sigma notation. Yeah, and then with the last one, let's say you have a fraction type of series. So you have a 1 minus 2 over 3 plus a 4 over 9 minus 8 over 27 plus dot dot dot. So they're usually 3 dots, and these 3 dots indicate that your series is going all the way up to infinity. This is what your 3 dots mean. So therefore you kind of won't have your last number because hey, it's infinity. So meaning your sigma notation will be something like this. So you're going to start from I, starting from 1, and then up to infinity like that. Yeah, this is basically how it's going to look like. So you're going to go on by saying this. I'm going to divide this series into the numerator and the denominator. Kind of going to have a formula for the nth term, a different formula for the nth term on both, guys. So for the top, we're going to have something that says what? 1, 2, 4, 8. And then for the denominator, we're going to have 1, 3, 9, and 27. Yeah. Now we can assign the sign either on top or the bottom. So I prefer the top, so it's going to be there and there like that. So I need to come up with a sequence for the top and the bottom. So again, what type of series is this? This doesn't look like an AP, so this is a GP. So I'm going to find my R. So my R for the top is going to be negative 2 over 1, which should be equal to 4 over negative 2, which should be equal to negative 8 over 4, which is giving me a negative 2. So that is my R. So my formula for the nth term is going to be A R n minus 1. So my A is 1. Yeah. My R is negative 2. This is going to be n minus 1. Yeah. So this one that is here, it kind of doesn't have an effect with everything that's this side, so I can just say negative 2 and then n minus 1. Can I say this? Can I say this? Can I say this? Yeah, I think I can say this. I think I can. I think I can say this. I'm not sure. Yeah. So if I say this, so meaning this is going to be my thing for the top. So it's going to be negative 2 and then n minus 1. So this is going to be the sum of the nth term for the top. So and also need to find sum of the nth term for the bottom. Yeah, sum of the nth term for the bottom. So what numbers did I have for the bottom? So for the bottom we had a 1, a 3, a 9, and a 27. So this being a GP, you can find our R, and our R is 3 directly. Finding that, meaning this is going to be a R n minus 1. So our A is 1. This is 3, and then n minus 1. So this is just 3 n minus 1 like that. So these are my two formulas for the nth term. So I can say, alright, my summation is starting from I is equal to 1 and then to infinity, and then for the top I had negative 2 and then in parentheses n minus 1, and then for the bottom I had 3 and then n minus 1 like that. Yeah, so having this, it should give me a really nice sequence that will follow up with what I have here. Yeah, so this is it. So this is how you find your thinking. Yeah. So aside this, yeah, I think this is it. Yeah, so you just need a few more practice on this, and yeah, you should be good to go.